Hi, this is Mr. Max with Sun for Mathematics. Now, um, you have to look at the time to see what time I'm busy with the videos. You can see it's quite late in the evening or early in the morning. So I do understand that there are some requests, and I'll get to it. Tomorrow, I'll be looking at my fifth tests that I have given to the AS level students. That fifth test, again, by request, I can provide you with the document. Let me just scroll to it. The fifth test has to do with sequences, series, as well as sigma notation and sum to infinity. So this fifth test I'm going to do tomorrow, um, just so that you can have it. I gave this test on the 7th of March to the AS level students. Some of these questions, you will see this question was in last year's question paper. I'm going to explain that tomorrow. There's just the reason why I'm doing, I sort of give a follow-up test, which is written today. Also, just to, because I was not quite happy with the outcome of that first test. So this is a follow-up test that I'm going to explain first, and then tomorrow I'm going to do the test 5. So test 6 is also questions on sequences, series, sum to infinity, sigma notation, and a little introduction into the binomial theorem. Of course, I'm going to be providing two tests on binomial theorem. I'm going to provide one this Friday, and next week I'm going to have the second one. All right. Also, the grade 11s have requested paper 2 of 2023. I'm also going to upload that one within this week. Okay, let's get to this question. So here it says the sum of the first 6 terms of an arithmetic progression is 72. Perhaps I can just go ahead and write that down, whatever, in order to make that a little bit interesting. It says the sum of the first 6 terms of an arithmetic progression is 72. And I think it's quite important that I highlight that this is an AP. So you use the correct formula for an AP. So this basically means that 6 over 2, and then I have 2a plus, so it's going to be 6 minus 1 times the common difference. Well, this gives us 72. And this is 3 over here, so I have 2a plus 5d is equal to 72. And what I'm going to do, of course, you have many ways. I'm just going to distribute this 3 over here. You could also divide that 3 into the 72. But this gives me 6a plus 15d is equal to 72. And I'll go ahead and I'll call that my equation A. Right. What else do I know? Well, I know that they are saying, giving me another piece of information, they are saying the second term is equal to 7 times the fifth term. So the second term is nothing but a plus, well, now you have 2 minus 1d, and that is 7 times a plus, that's 5 minus 1d. So this here on this side is a plus d, and this is 7 in brackets. I have a plus 4d. I hope you understand that. All right, so I'm just going to go ahead and I'm going to sort of distribute that 7 over. I'm going to write it this side, so I've got 7a plus 28d equals to a plus d. So again, just going to have everything on the left. So this is going to be 6a, and then I have going to have 27d equals to 0, and that will be my second equation. Right, so they want us to find the first term and the common difference. So I have got two equations here, and I'm going to solve these two equations simultaneously. Can you see the reason why I didn't divide the 3 into 72? I was looking at the 6a's here because I can eliminate by simply subtracting the two equations from each other. So I'll say equation A minus equation B. So I'm going to have 6a plus 15d, which is 72, and I'm going to subtract 6a plus 27d, which is equal to naught. It doesn't matter which one you write on top though. Okay, so I'm going to go ahead and do the subtraction. Obviously this one's eliminate, and 15 take away 27, that is going to be minus 12d, and that is 72. So this then gives me that d equals to 72 divided by negative 12. Let's just write our 72 neatly there. Okay, here we go again. So we're gonna sort of restart that particular thing there. Again, don't worry about it. It's just a little bit of technical issues this side. So I think it will resume wherever we stopped. Okay, so let's just restore that. So and finish our value of d. Our value of d therefore will be 72 divided, and that gives by negative 12. That gives us that the value of d is equal to minus 6. Of course, because of space now, I also need to find the value of a, and perhaps I'll just bring in maybe a blank page so you can see. And in fact, we can let's do that rather. Let me bring in a blank page. Okay, let's insert a blank page. Page, say insert a page. All right, blank page. Okay, so well, it's on top there. So what we know is from the two equations, I'll just quickly write them down. I had the equations 6a plus 27d, which was naught, and the other one was 6a plus 15d, which was equal to 72. And when we did our subtraction, we then realized that d is equal to negative 6. So I'm going to use 6a plus 15d equals 72, but now I know the value of d, so I'm going to substitute into the value of d. I'm going to substitute my negative 6, and that is 6a minus 90 equals to 72. All right, so this is going to give me 6a equals to 72 plus 90, of course, and if I go ahead, then I will have 6a is equal to 162. Then a will be 162 divided by 6, and therefore my value of a is 27. All right, so just to make sure that I have the correct answer, I know that my a value is 27, and well, my d value is negative 6. All right, so just ran out of space there. So this is the required solution to that particular question. All right, so let's go to that question, and I'll just go ahead and I'll write in my value of a. So we have now determined that our a value was 27. So now I can actually answer part B of this question. Right, part B says now you must find the sum of the first 10 terms. Now this is actually very straightforward. You use the S sub n formula, and that will be 10 over 2. And I have 2 times the value of a, which is 27, plus, now you have got 10 minus 1 times the common difference of negative 6. Now, you use your calculator, you obviously arrive at an answer here, and you will see that this answer is 5 here. That's 54 minus 54. Therefore, this answer is equal to 0. Okay, so that takes me to question 2. It says the sum of the first 2 terms of a GP. Again, perhaps necessary that you highlight the fact that you are now busy here with a geometric progression, and you just write down the information that we have. So the sum of the first 2 terms is equal to 9. So that becomes then a, then I have r squared minus 1 over r minus 1 is equal to 9. So let me just go ahead and have a, and then have r squared minus 1 is equal to 9, open bracket, r minus 1, and I will let that be equation A. And then perhaps I do the other one similar here, the sum of the first 4 terms. So the sum of the first 4 terms is equal to 45. You are supposed to be familiar with the formula, so r raised to the power 4 minus 1 upon r minus 1 is equal to 45. And this is a, r raised to the power 4 minus 1 is equal to 45, in brackets I have 1, or r minus 1 rather. And then there's something interesting developing here, r raised to the power 4 minus 1, and that is like r squared minus 1 and r squared plus 1, which is like the difference of two squares. And this can be my second equation, my equation B. Right, now I'm going to take these two equations and I'm going to solve them simultaneously. And the way I'm going to do that is I'm going to take equation B and I'm going to divide equation B by equation A. So subsequently, this is what I'm going to get. So let me just bring in. So I have got equation B, which is A, r squared minus 1, r squared plus 1, which is that 45 over r minus 1. So I'm going to divide that. I'm going to divide that story again. Is it not possible for me to just continue and see where it brings me? Of course, it's going to have quite an issue. Let's see. Let's just end it, close it, and just open it again. There is something that I'm pressing on the stylus, which is the pen that I'm using, and it's quite irritating. Just bear with me. Okay, right, so again I said we have got equation B divided by equation A being it's going to change the color there, which is A r squared minus 1, this one over here, well, that's equal to 9, and then r minus 1. Of course, I can simplify here by simply cancelling out. R squared minus 1 is cancelling, the a's are cancelling, r minus 1 is cancelling, and what I have here is 9 goes there 5 times, and I'm going to be left here with r squared plus 1. So I can actually therefore calculate my value of r. So r will be r squared equals to 5 take away 1. So that's r squared equals to 4. And that will be r equals to positive or negative the square root of 4, which is positive or negative 2. So I've got two possible values of r, because the question is asking me or telling me that there are calculated two possible values of the first term. So I must have two r values as well as two a values, which is the first term. Now, talking about the first term, and I can now calculate the first term, so I'll be using the formula to find the first term. So if you were to go back, you can use any one, so I'll use s sub 2 equals to 9. Okay, so I'll say that means, and very important that you do show these things step by step. So when if r is equal to 2, that is a, in bracket that is 2 squared minus 1 over 2 minus 1, which was 9. Well, that gives me a 4 minus 1, which is 9, equal to 9. That is 3a equals to 9. Therefore, a is 9 divided by 3, and therefore a is equal to 3. Okay, so if r equals to 2, that's what I have over there. So let me just continue to the next one. I'm going to use the same. Remember, we said we have two values of r, so if r equals to negative 2, then I'm going to use the same formula. I have got negative 2 squared minus 1 all over negative 2 minus 1. Of course, that equals to 9. On top, you have 4 minus 1 a over -3, that gives you 9. That is 3a over -3, that gives you 9. So here I've got -a equals to 9. So of course here the value of a is equal to -9. So I have therefore the two possibilities. So let's just write down what I have so far. You can always rewind the video. So I know that if r equals to 2, then a equals to 3. That means if I want to find the fifth term, I will be saying a, which is 2 times 3 raised to the power of 5 minus 1. Of course, that just gives me an answer. Then I can grab my calculator and you'll get 48. Then the other one, that is r equals to -2, and then the value of a was -9. So the fifth term would be that r value or a value, a, which in this case the a is -9. In fact, we should just maybe make a little bit of a switch over here, because if you have to look here using the formula correctly, okay, a is 3 and r is 2. So a, 3, and 2. Remember the formula is t sub n equals to a r n minus 1. Okay, just made a small mistake over there. Good. That brings me to this one. That is a and r is -2 raised to 5 minus 1 power. Of course, you can use your calculator and you are going to get those two answers. So the fifth term, you can go ahead then and answer the question. I say the fifth term, maybe I should just write it out. We say the fifth terms are 48 and -144 respectively. Okay, so this is what we're looking at. Right, let's go to the next question. Question 3 is sum to infinity. This is very straightforward. You just have to identify your a value as well as you identify your r value. Okay, so from this particular case, our a value would be, the first term would be 16. Our r value would be term 2 divided by term 1, which is nothing but 3/4. Thus, looking at our r value, the absolute value of r is less than -1. That now implies that the series is convergent, okay, tends to a number, and the sum to infinity will exist. Okay, so we can therefore find sum to infinity, which is a 1 minus r, that is the formula. A is 16 and 1 minus 3/4. Grab your calculator, you will see that your answer is 64. Question 4, you have got these recurring decimals that you are supposed to also then write as a fraction in the lowest term, obviously using the sum to infinity. And this is what it means. So you have got 0.235. Now the 3 and the 5 recur, that's why those dots are there. So this is actually 0.2353535 and so on. So this is therefore equal to 0.2 plus 0.035 plus, of course, now you have got 3, 1, 2, 3, so it was 0.12335 plus, you have got 5 here, 1, 2, 3, 4, 5, 0.12345. That's what it means, and so on and so on. So what you have is you have 0.2 plus an infinite excuse the handwriting, geometric series. With that part, with the first term equals to 0.035, and r will be nothing but if you take the second term, which is like 0.00035, and you divide it by 0.035, you'll get 1 over 100. So in a nutshell then, it means it's 0.2 plus the sum to infinity. Right, so let's just continue to the next page. So I will then say, using the sum to infinity of a1 minus r is the formula. I have 0.035, that is the value of a, and then I have 1 minus 1 over 100. And if you were to punch that in, you get 7 over 198. Let's just confirm. So we have got 0.035 over 1 minus 1 upon 100. Of course, you get 7 over 198. So at the end of the day, I will say, therefore, 0.235, with that bit recurring, is 0.2 plus that 7 over 198. So you can just go ahead then and finish it. Right, remember 0.2 is nothing but 1 over 5 as a fraction. But you can also go ahead and use your calculator to just say that answer plus 0.2, rather 0.2. Well, you get 233 over 990. 233 over 990. Okay, and this is the answer to our question. And you can just go ahead and test it. So if you take that fraction, yeah, you'll see that the 3/5 definitely will repeat itself. Hence, you have the lines on top of that. Right. So we have another question. Question 5. You're supposed to express 1 plus 4 plus 7 plus 10 plus 13 plus ... and then you're given the last term of 298 in that form, where you have the limits of summations between r equals to 1 up to n, and f of r is the expression. So this one here is the expression for the, I'll say, rth term, because there's a r involved in the index over here. And you can do inspection. If you do inspection, so by inspection, you just obviously look and see, I can actually find what that formula is, or that expression is. You can say that 1 plus 4 plus 7 plus 10 and so on would be, has the rth term of 3r minus 2. That is what you can see. You can see the first term. You can see the common difference 4 minus 1. Or alternatively, if that is not what you are able to do, alternatively, you can say, had we not been able to state what I just stated on top here by means of inspection, we could say, now here it involves that you are supposed to prove that this is an arithmetic progression. You could say that 1 plus 4 plus 7 plus 10 and so on is an AP. It's an arithmetic progression, with A equals to 1 and D equals to 4, take away 1, which is equal to 3. And if that is the case, we'll say thus the R term, would be A plus Here I'll have r minus 1 now times d, which is 1 plus r minus 1 times 3. Well, if you clean this up, you're going to end up with nothing but 3r minus 2. Okay, so if that is the case, there's one more step that we need to do. What do we know? When you look at how the sequence is given, you have got the series there, and then plus the last term is 298. Thus, as the final term, now I'm just writing these things just for explanation purposes, okay? As the final term is 298, the greatest value of r in this series for which 3r minus 2 is equal to 198 will be, let r, if you have to, move over, that's to 198 plus 2, that will give you 200, that's it. And of course, this is not 198, but it's rather 298. So I think I made a mistake from writing down the value there. 298, and that will give you that r is 300 divided by 3, which implies that r will equal to 100. Okay, now we can actually go ahead and we can say, okay, I can actually write it down, and I can say, therefore, 1 plus 4 plus 7 plus 10 plus 13 plus dot 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 plus 298 equals to, use the sigma notation, where r is equal to 1 up to 100, and here I have 3r minus 2, and that's the solution to that. Good. Let's move on. Let's go to question 6. Now, question 6, obviously, this one was also in the AS level question papers of last year. Now, since I haven't really started with binomial theorem beyond the point of Pascal's triangle with my learners, we're going to use, Pascal's triangle in order for us to find the first three terms of this expansion. Now, you do know that if you were to use Pascal's triangle, you have got 1, then you have 2, then you have 3, 3, 1, 1, 2, 3, you have 4, 6, 4, 1. Of course, I hope you also know how one get the answers. Alright, so if you were to add these two, you'll get this. If you add these two, you'll get this value. Adding 1 plus 3 gives you the 4, 3 plus 3 gives you the 6, and 3 plus 1 gives you the 4, and it's always flanked by 1. So the coefficients will be 1, 4, 6, 4, 1. Alright, so what do I know? I know that 3 raised to the power of 4, but maybe perhaps I'll put this in bracket. Then I have ax raised to the power of 0. Remember, these two should add up to that 4. But here I will have 1 plus, then 4, and let's just bring back the black color. Then I have got 4, which is over there, and then this is going to be 3 raised to the power of 3, and ax raised to the power of 1. Then I'm going to have plus, of course the coefficient is 6 now over there, and I'm going to say, what is it? It's 3 squared ax to the power of 2, because these two should give you 4. Okay, and so on. Right, that's all that I need to work with, and I'm going to calculate this, and I'm going to write it down. So 3 raised to the power of 4 is 81. Ax to the power of 0 is just 1. Now I've got 4 times 3 cubed. That's the same as 4 times 27. So let's just bring it in. 4 times 3 cubed. That's 108. So I have got 108 over here. Ax plus, now I've got 6 times 9, 6 times 9 here, that is 54, then a square, x square. That's the first three terms that you are looking for. Find the first three terms, term 1, term 2, term 3, okay? So this is the first three terms using Pascal's triangle. Now, very important that you don't get that wrong. Now they say the coefficient of x squared, we're supposed to do something here. They say the coefficient of x squared, that expansion is 1081. So what we're going to do is we're going to say 1 plus 4x and then multiply that. Let's take the first three terms of the answer that we got in part 1, which was 81 plus 108ax plus 54 a square x square. Just the first three terms, okay? And what that tells us is we want to see what do you multiply here to get an x square. If you were to take 1 times 81, it's not going to give you any x square in there. But if you were to take 1 multiplied by 54 a square x square, that means that 54, this one over here, times that is going to produce that x square. So I'm just going to write 54 a square. The 4x times 81 will not give us a square term there, but the 4x times the middle one here will definitely. So 4 times 108, positive 4 times 108, so just grab your calculator, you say 4 times 108 is 432. So that is 432, that is going to be 432 a square, 432 a over here, sorry, I'm here, 4 times 108, that is just going to be 432 a. And if you multiply x by x, obviously you're going to get the x squared. So I'm going to say let this then equal to 1080. So the reason why I don't go 4 times this one here, 4x times that one here, the x square, and that x will make it cube. I'm just interested in the ones where the coefficient of x square, whatever the coefficient will be, 5a, 54a square and 432a, let's say equal to 1080. Of course, this becomes a quadratic equation, and you have got 54a squared plus 432a, and all quadratic equations are supposed to equal to 0. And if you have a look at this, you will see that 54 goes in all this. Here it will be a squared. 54, if you divide that by 54, it's 20. It's 8. 8a, and 1080, that's where I thought 1080, if you divide that by 54, because you get 20, that's minus 20. Now the equation looks kind of easy for us to find, because here the question says find the possible values. Again, very important, possible values of a. That implies that there will be more than one answer for the value of a. So hence you have a quadratic equation that has got two solutions. And I can factorize, obviously, and this is a negative, so one bracket will be positive, one will be negative. It's 10 and negative 2. So a plus 10 equals to naught, or a minus 2 is equal to naught. This implies that a equals to negative 10 or a equals to 2. And these are the two solutions to this question. I'm just going to put it in a rectangle there, just so that we can always refer to what the answer would be. All right. Of course, you could use the another way, not the binomial theorem, when you wanted to calculate those first three terms. But I thought, well, I've started off with an introduction to binomial theorem by using Pascal, and that is what I've done over there. All right, so that is the end of this test. I'm just going to remind you that obviously there will be two more tests that are going to be followed. Whenever you request this document, you'll see that I've included the formula as we move along. When I do the in-depth test on the binomial expansion, I'm going to be explaining this formula. These are formula that you get in the question paper, and it's important that one explains them so you can understand the and factorials and stuff like that. And question test 7 obviously will be part 1 will be on binomial expansion, and part 2 will also be on binomial expansion. So I'm going to look at exam style questions and stuff like that, so you know how to approach the questions in the examination. All right, so just to also re-emphasize what I said, this is my obviously this was my 6 tests of the AS level syllabus. So far there will be a lot more tests. This document, you can see, it will go all the way up, maybe up to 300 pages, until we are done with the whole AS level syllabus. So I'm going to do tomorrow my 5th test, which is also work on sigma notation, series, and sum to infinity, and a little bit of more on sequences. I'm going to do that tomorrow. Okay, it is kind of late now, and then I'll also see if I can also then look at grade 11 paper 1 that was written last year. Good luck with your studies.